Okay, ladies and gents, this is your part B of your logarithmics section 7.4 note guide. Just a review, logarithmic form in general form, is shown right here. If we want to switch it over into exponential form, we can switch it to look like that right here. And we'll be doing that a lot. So just kind of, again, that's where I was saying if it's a little confusing, just kind of bear with me on that. But before we get into that, let me just talk about the most common I should say, the most frequently used logarithms. One is the natural log, and we use ln as abbreviation for the natural log. You can find that, by the way, in your calculator. Let's see, it's like the second, you'd have to hit the second button, and then you'll see the ln button there, or in the top part. So just kind of actually, now that I'm looking at it, oh no, I'm sorry. The natural log button is right next to the for button. But if you want to, well, let me take a step back. So a natural log is ln, and it has a base of e, the number e. And you may never have talked about the number e ever in your life. And I just want to let you know it's kind of like very similar to like the number pi, where it's irrational. And this is where if you hit the second button and the ln button, the natural log button, that will take you to the e to the x and put like to the first power in there, and you can then approximate the number e very easily. So just like if you push the pi button, you can see the approximation for that. Well, you can do the same thing. That's where I'm getting this number from right here. And it goes on and on and on forever because it is, again, irrational, just like the number pi. Okay. And that is a number that is used in math, most notably, at your level, to compound interest continuously. And we'll be talking about that actually in the next section or the section after that. But anyway, so that the number e is an important number to know, and kind of keep in mind that ln, natural log, is used as when you have a base of e. Common log, well, it says common, so it must be the one that's used most often, but we use log, which spells log, logarithmic. So remember, log is an abbreviation for logarithmic, and just like trig in trigonometry, to give you an idea. And that has a base of 10, and we love base of 10 because everything is so much easier to calculate with a base of 10. If you don't know what I'm talking about, think about our money system. But anyway, or the metric system, more importantly. So those are the two most common, or again, I can't use the word common, most used or most popular logarithms. So let's do this example 2 down here. It says rewrite in logarithmic form. So right now it's in exponential form. What it's asking for us to do is to switch it over to logarithmic form. So I'm going to just note, first of all, that the exponent is x. And in a logarithmic form, you're always setting the exponent equal to the exponent. So I'm going to go log. The base is just like the base of the exponent, right? So base is 3, so I'm putting that as a sub 3. It's actually in the subscript. It's not at the same level, and you need to make sure you write it that way. So log base 3, 20 equals the exponent. So that's the easiest. When you start doing them, you'll get better at them. But I'm just letting you know the base is the base. We're used to that. The exponent is always what the logarithm is equal to, and then the 20 is actually the last thing that's left, right? So let's do this one right here. I know that the base is e. I know the exponent is 5. So I can say log base e of y equals 5. Again, the logarithm is always set equal to the exponent. Now, I would never write it this way. Now if you do initially, that's fine. But because of this log base e, we know log base e is actually better written as the natural log y equals 5. So this is better. Now, again, you're just beginners with this, so it's going to take a little bit. So just kind of keep in mind that this right here is the same thing as saying natural log. Okay, so we're going to do the same thing here for letter C. I know that we have a log. The base is 10,000, 1, 2, 3, and that is going to equal my exponent. Now here's another one where this is the common log. If you write it like this initially, it's not a huge deal, but we would never, as you get going, would never write this like this. You tend to write it just as log 10,000 equals 4. And the reason I'm saying that is that it's kind of like, remember when you first started learning algebra, you'd always write 1x. But after a while, you're like, well, I don't need to write 1x. I can just say x. Same thing, you know, x to the first power. You don't write x to the first power. You just write x. And we already know that it's to the first power. So that's kind of what log, the common log and the natural log is kind of like, because it's used so frequently in logarithms that we tend to, we have shortcuts for them. Okay, so now let's go do the reverse here. So I'm going to want to switch this into exponential form. So really all we're doing is kind of getting used to logarithm and exponential, or switching it back and forth, and just kind of baby steps with logs. So here we go. We know that this is the exponent. So these are always the exponents. And we know the base is whatever is in the subscript. So I have 4 to the third power equals x. And if I want to get really, really fancy, you know, this is saying rewriting, so we'd leave it like this. But if it actually were to say evaluate, like example 4 is going to do, that's when you would go 4 to the third power and actually write that out. So here, let's do this. Notice that there isn't a subscript, so it is written as a log 4. So we know the base is 10 because this is a common log. Kind of like that example C and example 2, or example 2, letter C. So 10 to the y equals 4. Oh my gosh, what did I just do? I was thinking about something totally different. I'm sorry. Look at me. 10 to the y. Oh my gosh, I did it again. Yeah, no, we're good. Oh gosh. Have you ever done where you're just like, sorry, bear with me. So I was actually thinking about going grocery shopping. I'm sorry, I need to kind of keep my head in the video. Anyway, so 10 to the y equals 4. Okay, so this over here, now of course I circled my exponent, I can't read it then. This here, we have a base of e. Now, you know what I'm going to do is this one, I'm going to actually rewrite it as log base e. It's not written there. And then look at this one. This has e up there equals z. So I'm just rewriting it as a log so it's a little bit easier to see, kind of like, well. So this is base e. I'm going to write over here, e to the z power equals e. And again, all we're doing is writing these in a different form, a form that you're much more comfortable with. Again, since you've only seen logarithms a very, very short amount of time here. Okay, so kind of getting used to a logarithm, but now let's actually evaluate them to show you the power of them. And it says evaluate the following logarithms without a calculator. So really note that you're not using a calculator in these examples. I will say this. Eventually you will not need to switch forms. You will not need to put an exponential form to be able to evaluate these, but initially I've got to tell you, that is the biggest hint I can give you. So my hint to you is to switch forms. You've worked with exponents for a long, long time, and you've only seen logarithms now for, I don't know, about a half hour? So just kind of keep that in mind. So this is without a calculator, and my advice to you is switch forms. Now, when we do switch forms, notice that the logarithm isn't equal to anything, so you can just set it equal to something. You could set it equal to a question mark. You could set it equal to a smiley face. In this case, I'm just going to set it equal to x. Okay, you could use whatever variable you want. But really what we want to know is what is x. So what is log base 381? So we're going to switch forms. So I'm going to go 3, the base, raised to the exponent equals 81. And this is where I'm going to note to you, or make sure that you recognize this, log base 381, when you evaluate this, really what you're trying to find is what the exponent is. You're trying to find the exponent. And a lot of times I say, keep in mind, besides a log being an inverse with an exponential, really when you evaluate a log is an exponent. So now what we're thinking about is, okay, 3 to what power gives me 81? And that's where you're going to go, okay, 3 squared is 9, 3 cubed is 27. Oh, you know what? X is going to equal 4. And yes, you need to know your exponentials. You need to be able to go, okay, 3 squared is 9 in your head, 3 cubed is 27, and so on. Okay, so that is the trick to this. Switch over to exponentials and then look to see what you have and try to figure out what would make it true. And again, I used X. You don't need to use X. You can use Y. A lot of times sometimes just to prove my point, I put a question mark here. That's supposed to be a question mark. So that when you switch it over, you're like, okay, 4 to the question mark, 4 to what power gives me 0.25, but I'm going to switch that over to a fraction so it's a little bit more obvious. 1/4. So 4 to what power gives me 1/4? Well, here's the thing. 4 to the first power gives you 4, but 4 to the negative 1 would flip that 4 into the denominator or do the reciprocal. So this question mark is equal to -1. Now, when people say logarithms are hard, they actually don't mean that logarithms are hard. What they mean is that they are not very comfortable with exponents in general. And then when you have to use them in an inverse kind of way, students really find it hard. So if you were never comfortable with exponents, especially negative exponents, fractional exponents, all those, that's where you're going to need to kind of get that practice to make sure that you're feeling comfortable here. So really, it's not that logarithms are hard, exponents are hard. But with that said, it is what it is. Okay, so let me just kind of keep going. So log base 1/4 of 256 is equal to what? And I'm going to just, for fun, change it to a y now, just so again you can see it does not matter. Okay, so I'm going to go 1/4 raised to what power is going to give me 256? Now my advice is go 4 to what power gives you 256, and you should know, or at least will learn to know, that 4 to the 4th power is 256. So we have 1/4 though. And so 1/4, if we want to get that up into the main floor, we're talking about a negative exponent here. So you're talking about y equals not 4, but -4. So this sometimes, again, this is where I'm saying you're using inverses with exponents, and that's what gets people a little confused. I'm going to do something different down here if you are having trouble following me. That 1/4 to the y, I could write it also as 4 to the -1, which is the same thing as 1/4, y equals 256. Now we know, again, that 4 to the 4th power is 256, and that 4 times -1 is going to give me that -4. So you can write it a little bit differently using your different exponent powers to kind of make it a little bit more understandable if you need to. Okay, so right here, I'm going to, actually, oops, I didn't want to do that. I'm going to do this. I'm going to try to make that bigger. There we go. So again, I'm just going to set this equal to x. I'm going to switch it over. The base, 49, raised to the exponent equals 7. Well, you can see the square root of 49 is 7. And again, with square roots, we know that that's the same thing as saying x to the 1/2, or 49 to the 1/2 is equal to 7. And again, it's the exponents, knowing your rules of exponents from first semester advanced algebra. It's going to be kind of a test on your patience here. This here is very similar to the very top one, so this one is on your own. This one here, 16th to the 4th, is very much like the last one we just did, so that one is on your own. This one here, so I'm just going to test you on your knowledge on that when you come in and show me your note guide. This one here, again, there's no base there, so I'm going to just remind you that if you don't have a base, the base is 10 to what exponent is equal to 100. And this is going to be that the question mark is equal to 2. So your answer here is 2. Now I do want to say I put the question mark, I put a variable. You could also just say, hey, you know what? This equals 2. That's your answer. This one also is kind of using, instead of the common log like we just did, it's using that natural log. And let's switch it over into the right form. Again, I'm going to just use a question mark. So I want to know what the natural log of e to the fourth is. Well, we know the base is not written, but is written as natural log. So we know the base is e to the exponent equals e to the fourth. So this here is, there isn't really a name for it. You have the base, you have the exponent. It's the other thing. That in its entirety is going to go here on the right-hand side. So now think about this. E to what number is going to equal e to the fourth? Well, clearly you're talking about that the question mark is going to equal 4. So the answer here is 4. So that is really the nutshell of the very first section, which, we're not talking about logarithm powers yet or anything, or the properties and so on. And that's kind of what we're getting into next. And then after that, I'm going to show you how to use logarithms to actually solve exponential equations, which is where the power really shows. But just kind of a revamp here. So this section, just kind of taking a step back, because you really need to see the big picture and all the little pieces too, is the very first thing we talked about was that a logarithm is an inverse of an exponential. So, and it's going to reflect across that line y equals x, and they literally, all their important information, the domain ranges and all that, are inverses of each other. The switching of the x's and y's. Then I really got into how you go from log form to exponential form and vice versa. And so down here, that's the first thing we wanted to do. We rewrote a logarithmic form as an exponent. We went from exponent to log form. Then we went from log form to exponential. That is the baseline trick to start with in order to understand what it is you're trying to solve for. Example 4 really is kind of now getting into more of the solving, which is in this case is evaluating, but same, in this case you'll see how it's kind of similar. And really understanding that when you're evaluating a log, you're literally finding what the exponent is equal to. So if you're understanding these examples in 4, you are doing fabulous. So get going on the practice, and then I'll help you with any questions you have. Take care.